Okay, what I'd like to do in this video is actually work through some stoichiometry problems and show you the different ways these things can be solved. Again, I'm going to be referencing my molar conversions over here on the side, and we're going to be using this sample problem. As a matter of just acceptance here, we're going to assume that these are all gases, and they actually are. It's not an assumption. And water, when it is produced in this reaction, this is a very exothermic reaction, the water will come off as a gas. So just recognize that these things are all gases, which will allow me to do these conversions, and we're going to assume we're at STP. All right, as I mentioned before, these numbers, the coefficients, give you the ratio of the atoms to one another, not their mass, but the number of. So what we need to do is compare the numbers of hydrogens to the numbers of oxygens and the numbers of waters. And I can compare any one thing to any other one thing in this equation. The problem or the issue that comes up sometimes is that when I am doing this, I'm not given the numbers of particles, I'm given the masses of particles or the volume. So what I have to do, and I showed in the first stoichiometry video, is I have to turn whatever I'm given into a common counting unit. And in chemistry, the common counting unit that we use is the mole. So as an example, let me do a mass to mass sort of problem. Let's say I start out with, I don't know, just let's say 10 grams of H2 in this reaction, and let's say I would like to know, well, how many grams of water will be produced from this reaction, assuming I have plenty of oxygen. So I have 10 grams of hydrogen, I'm going to react. Okay, what I want to do is I want to compare the hydrogen to the water. So what I have to do is, since I'm dealing with numbers of things, I have to turn this into a number, so I'm going to turn this into moles. So we're going to call this a mass to mass problem. I'm going from the mass of one thing to the mass of another. So what I'll do is I'll start with my 10 grams of H2, and to go from grams to moles, I'm going to have to divide by the molar mass. So using dimensional analysis or factor label method, I'm going to put grams of H2 here, moles of H2 here. In these problems, it's always going to be 1 mole is, and then I'm going to use the conversion factor. Since we're dealing with mass, we're going to use the molar mass. If you look in your periodic table, hydrogens are 1 each. I have 2 of them, so I'm going to put 2.0 there. Now, my next conversion is, now that I know the number of these particles, I can compare that to the number of whatever I'm trying to find. I could go to the oxygen or the hydrogen. The thing I start with always goes in the bottom, so I'll go from moles of hydrogen, and I could go to this or this. In our case, we're going to water, so I'll go to moles of H2O, and these numbers come from the coefficients. So what happens is the 2 will go here, and same thing here, the 2 will go there. So basically, however many moles of this I have this as well. It's a one-to-one relationship. If I was going to oxygen, I'd put 1 mole of oxygen here. Now, at the end here, what I want to know is the mass of the water. So what I will do is I will go from moles of H2O, and basically I'm going from 1 mole to the molar mass of water. If you look on your table, oxygens are 15.999, so we're going to round that to 16. These are 1 each. So that would be 18.0 grams. And this is of water. So what I've done, and let me kind of color code this a little bit for you. This first part here is simply the process of taking whatever I'm given and turning it into moles by dividing it by whatever conversion unit I have over here. The second part of these equations is this molar bridge, and what happens is the moles of what I'm given always goes in the bottom, the moles of what I'm trying to find will always go on top, the numbers will come from their coefficients in the balanced equation, and then the last conversion is where I'm going to multiply by the conversion, because now that I know the moles of my final thing, I multiply by my conversion to get my final answer. So all I do at this point, and let me go back to black here, is I'm going to take 10 divided by 2, basically, which gives me 5, times 2 over 2, so I still have my 5, times 18, excuse me, and 5 times 18 is, I believe, approximately 90, if I'm doing my math right. So I have, if I make this 10.0, I have 3 significant digits, so I could make that 90.0 grams of water. So what this is saying then is, if I react 10 grams of hydrogen with plenty of oxygen available, I would get 90 grams of water. Now this is a mass to mass, as I said a moment ago. Let's pick another color and let's do a volume to volume problem. and I could do the same thing. Let's use the same numbers. Instead of 10 grams, well, let's use different numbers just so we're clear on it. We'll say I've got 5 liters of hydrogen, and just to go for something different, let's say how many liters of oxygen will be required to react with 5 liters of hydrogen. Same thing. I'm going to do my first part where I'm going to take my 5 liters of H2, and we're assuming I'm at STP so that I can use my 22.4 over here. And then I'm going to go from liters of H2 to moles of H2, and again, just like here, it's 1 mole is, and I use my conversion, in this case it's 22.4 times in a line, and I'm going to go from moles of H2 to moles of what I'm trying to find, which is O2 in this case. Now here I have a 1 in front of the O2 and a 2 in front of the H2. So again, these numbers in this section here come from the coefficients of the equation, and then at the end I'm going to go from moles of O2 to liters of O2. And again, it's 1 to 22.4. So notice always in the beginning it's 1 mole over my conversion. At the end it's my conversion over my mole. This is assuming I was not given moles and I'm asked for something other than moles. If I'm just going from moles to moles, as you saw in the first video, I can just simply multiply by this red, the conversion here, and I'm good to go. Now the other nice thing with these is if I'm going from volume to volume, you'll notice my first conversion is 1 over 22.4, my last conversion is 22.4 over 1. So from a mathematical standpoint, these are going to cancel out, so really all I'm left with is 5 over 2, which is 2.5 liters of O2. So what would happen here is if I am reacting 5 liters of hydrogen, I'm going to need 2.5 liters of oxygen. Now there's a third way we could do this, just to throw it out there. It's not something you would really do in a lab situation very often, but when you get into these kind of theoretical things, you can do it, of course, is I could give you numbers of molecules. And again, this would be like going from numbers to numbers. And let's say I said you had 4.9 times 10 to the 23rd atoms of hydrogen. Again, I would basically do the same thing. I'm going to do atoms of hydrogen, or actually, let me apologize. That would be a molecule, and we'll call this molecule. So I'm going to go from molecules to moles of H2. And again, notice I have this 1 mole. My conversion here, of course, is 6.02 times 10 to the 23rd. And then I'm going to go from moles of hydrogen to moles of whatever. Let's do water, I guess, just to keep mixing this up. And again, my relationships there are 2 over 2 times, and now I'm going to go moles of H2O to molecules of H2O, and that is going to be 6.02 times 10 to the 23rd over 1. And again, just like here, notice my conversions for this and this are always going to cancel each other out. So if you are given atoms or molecules and ask for atoms or molecules, really all you need is the molar conversion. If you're given liters and ask for liters, as long as you're at the same temperature and pressure, your conversions there will cancel out. So basically what I'm left with here is 4.9 times 10 to the 23rd molecules times 1 over 6.02 times 2 over 2 times 6.02 times 10 to the 23rd over 1, and you'll notice basically all of this is going to cancel, and so my answer is going to be 4.9 times 10 to the 23rd molecules of H2O. And so that would be going from atoms to atoms, or molecules to molecules, or formula units to formula units. Now, you don't have to be consistent like this. We could go from mass to volume, volume to atoms. You could go a lot of different directions, but you need to understand that if you are converting, your first conversion will always be 1 over your conversion unit. If you're given atoms or molecules, it's going to be 1 over 6.02 times 10 to the 23rd. If you're doing mass, it's going to be 1 over the molar mass. If you're doing volume, it's going to be 1 over 22.4. Your conversion at the end will always be something over 1, your conversion over 1. If they want atoms or molecules, that'll be 6.02 times 10 to the 23rd over 1, your molar mass over 1, and your 22.4 over 1. In this middle portion right here, what I call the molar bridge, is always going to be the moles, which you get from the coefficient, of what you're going to, over moles of what you start with, again, which you get from your coefficient. So I hope this helps you see the problems and how you would actually go about solving a couple of different types.